Alright, bearings. So this is our last topic for trig for a bit, until mainly year 10, but bearings is probably the trickiest part of trigonometry in total. Just because bearings themselves are mainly worded questions, and they're always asked in stupid ways. So, the bearings. Let's start off with the basics. This mariner's compass shows 16 different directions. You should be familiar with them: north, south, east, and west. Halfway between north and east is northeast, halfway between east and south is southeast, halfway between south and west is southwest, halfway between north and west is northwest. Okay, so that's 1, 2, 3, and 4. And 1, 2, 3, 4. Then you've got your subcategories, so halfway between north and northeast is north-northeast, because you're more north than you are northeast. And it basically continues like that. East-northeast, because you're more east than you are northeast. East-southeast, because you're more east than you are southeast, and so on. I'm not going to say more because, I think you guys can read. Now, with bearings, we're going to be looking at these, but it's not the only type of bearing that we've got. We've also got something that is called a true bearing, and we'll have a look at those in a moment. But for now, bearing is a bearing is an angle measured clockwise from north. So basically, you're looking north, and then you turn clockwise until you get to the point or the direction that you want to go. Okay, so it's an angle. It is written using 3 digits. For example, 008, 032, and 144 degrees. So from north, basically we're saying, okay, so 008 is that you turn 8 degrees, and that's that. 32 is, we'll go a bit further than 8, go to 32, and that's that angle there. 144 is, well, we're going to go past 90, and then we're going to go to 144, and that's that one there. Okay? It's basically just how many degrees do you turn from north. Okay, sometimes the letter T is used to stand for true north. Okay, so basically, when we say true north we're talking about, well, how far is it from that north spot? So, for example, northeast is 045 T, or 045 degrees T, because it's 45 degrees from that north direction, okay? So have a look here. We've got our different denominators. So from north to east is 90 degrees, because that in there makes a right angle. So east is considered 90 degrees. South is considered 180 degrees from north, because you do have to do pretty much half a circle. West is considered 270 degrees, because if you're facing north and you turn clockwise, you have to turn 3 lots of 90 degrees. And then north is considered 0 or 360, because you do then have to turn all the way around. Now, it does work as if you keep going as well. So, for example, if you did 450 degrees, that would mean that you've done a full lap plus another 90 degrees like that. We're not going to be too concerned about that, but it's good to know, because in later years, say year 10, 11, and 12, it comes up a lot, particularly on the level of maths that you're doing. So, with that being said, you can also do the negatives ones as well. So if I say, negative 10 degrees, that just means that starting at 0, I'm going to go 10 backwards, okay? Again, you definitely won't be seeing those ones in year 9 or year 10, but, it's just good to know. Okay, to describe the bearing of an object positioned at A from object positioned at O, we need to start at O, face north, and then turn clockwise through the required angle to face the object at A, okay? So it's basically what I'm saying. Looking north, turn that many degrees, that's how you find your bearing. When solving problems with bearings, drawing a diagram including 4-point compass directions, so the north, east, south, and west at each point. So if you know you're starting at the point O, draw your lines, or your compass rose, and then draw the angle. And then go there. Because then if you're going to go back, do it again and make life a lot easier for you, okay? It really comes in handy. And this is a big issue I see a lot with these types of problems, is that students, like you, maybe not like you, but students don't actually understand why they need, a certain amount. Why is this equal to 70 degrees? Why is this equal to 150 degrees? This is just a good way, or it's a foundation for a good way to actually get your head around the mechanics of why these angles are what they are, okay? So drawing something like this, if you're doing points to and from, is a really good way to start getting your head around it. Now, this is example 1 from question 1. I'm really hope I don't have to go through too many of these. But let's say, for example, north we know is 0, 0, 0 or 360 degrees. Okay, 3 numbers. East 0, 9, 0. Southeast, let's do south. South's 180. Southeast, what's halfway between 90 and 180? Okay, 135 degrees, and so on. I'm going to let you guys finish off that one, okay? But I just wanted to go through that one really quickly just to make sure that you guys realize or understand how to do those ones. Okay, question 2. Write down the bearings shown in these diagrams. Use 3 digits for example. So for example, 0, 4, 5 degrees. I believe I actually haven't done any pictures for these because I believe I was going to draw them. So, yeah. So, let's say, I'm only going to do 2 for this one. So here's our compass rose. So we'll go north, south, east, and west. And I'm going to draw arrows on all of these ones because it's a compass. Okay, so this is going to be question 1 or question A. And this one over here will be question B. Okay. Now, the reason why I'm drawing these ones is A, these are really hard to find. Okay, and B, I want to draw specific ones for you. So, let's have a look at, one, for example. So let's say, for this one, it is 70 degrees from east. Okay, so the question becomes, well, how do we find the 3 number bearing for this? So again, remember, if this is your starting point and you're facing 70 degrees down this way, okay, you start by looking at north. So we're looking in this direction here, and then you're going to turn yourself clockwise until you get to the part that you want to get to. So to go from north to east, well, we have to go 90 degrees for that one. Then to get to the point that we want to go, we have to then travel an extra 70 degrees. Okay, so 90 plus 70, well then therefore this angle is, or the compass bearing for this one, is 90 plus 70 degrees, which is equal to 160 degrees T for true north. So 160 degrees from that north one there, okay? Now part B for this one, so part B, I'm going to make this B a little nicer and this A a little nicer. Okay, so part B for this one, let's get my red back out. Okay, let's do one over here, like this. Okay, but this time, it's going to be 55 degrees from that way. Okay, so there's 2 ways you can do this one. Okay, both of them are pretty straightforward. We know to go from here to here, so remember we're starting by looking at north, okay, and we should go around. So from there to there, it's 90 degrees. From here to here, it's 90 degrees. And then we can say to ourselves, well, what's this angle in here? How can we work out that angle in there? Well, we know that this whole angle here must be equal to 90 degrees. Okay, so we know that all must add up to 90, okay, from here to here. We already know that this part here is 55. So what does that mean that we've got left over here? Well, hopefully you've picked up that it's 90 minus 55 degrees, which gives us an answer of 35 degrees. Okay, so that's equal to 35 degrees. Okay, so then all we need to do is add the 90, and the 35. So 90 plus 35, and that gives us 180 plus 35, which is 215 degrees. So this one down here is 250 degrees T for true north again, so from the north around. Now, the other way to do it is to realize, well, we know that west is 270 degrees exactly. We know that this part is 55 degrees down here, okay? So all we need to do is we need to say, well, what's 270? And if we're going backwards, let me write this. Alternative, I'll draw a line going down there. 270, if we're going backwards, minus 55 is equal to 215 degrees true north. Okay, so you can use either of those methods for that one. They both work. They both give you the correct answer. Okay, now, I believe that makes sense. Okay, So for question 3, now these are the more typical types of ones we're going to get. Here's a picture. Now, we want to work out what's the bearing of A from O. A hint, it's very easy. And then we're going to do of O from A. A hint, not as easy. A from O. We want to go to A from O. That means that we're traveling from O across to A. What's the bearing of that? I hope you can see it. If I'm looking north, and then I go around the circle until I get to the point where I want, what's the value? So this one's nice and easy. It's actually already got it there for us. And most of these ones will actually have them there for you. 285 degrees is what that one is. Okay, so that one's nice and easy. Now, for the tricky one, of O from A. So now what we need to do is we need to go back in the reverse order. Okay, we need to actually go back in this direction. So as I said at the start of this video, the easiest way to start off is by drawing a compass rose straighter. Yeah, good enough on this one here. And then we need to find out, well, what's this angle in here? Okay, or sorry, what's that angle in there? And then what's the total angle to get to there? So we can already see that we have to do 90 degrees for that part there, okay? 90 degrees for that part here. Now we just need to work out, well, what's that little angle in there equal to? How can I work out what that little angle is? So the reason why we want a compass rose on both, ooh, that's gross, on both of them is because we can use this alternative angles theorem. The one where, you know, if both people are looking in at each other, one looks down the same as the other person looks up. Okay, so 90, 90, 90, that makes 270. How much is left over in this little gap here? Well, it's only 15 degrees. Now, using using that alternate angles rule, this angle in here is the same as this angle in here. So this one in here should also be equal to 15 degrees. Okay, so 90 plus 15 degrees is equal to 105 degrees. So my bearing is equal to 105 degrees, okay? And that's it. These ones are a lot trickier. Make sure you start off by drawing your compass rose. And in fact, they've in the question in the textbook, they've actually drawn the first compass rose for you. You just need to add in the second one, okay? Use that alternative angles rule and find out what that one is, okay? Now, let's do our fourth example. So these are questions 4 from 6, and this is one that yours will look like more, okay, for that previous one, by the way. So see how it's already got the compass rose drawn for you? Yeah, that's what it looks like. Okay, so wordy questions. A fishing boat starts from point O and sails 75 kilometers on a bearing of 160 degrees to point B, okay? So, here's my diagram over here of this situation that's happening. We've got the 75 kilometers that's happening across there, okay? The bearing of 160 degrees, which is this bearing in here, okay? That's that length in there. And, whoops, and that's all that we've been given. So, what we need to find is how far east to the nearest kilometer is the starting point of this boat. Okay, so basically we're asking, so here's in line of where it started. So if it just went straight down, it would not have went east at all. So what we're saying is, well, how far east did this thing actually travel? Okay, so let's call that a letter. We'll call that a little e for east. How far east did this travel? Now, I hope that you can see that there's a little right angle triangle sitting there. Okay, so I'm going to bring that out across like this. And I'm not going to draw it straight. Okay, there's that little right angle in there. Now we've got how far east it's traveled. We've got the 75 kilometers in here. Okay, now we need to work out, well, what's the angle? Okay, what's the angle? What's the angle in here particularly? We want that angle. So looking back over at my diagram, I can see that it goes 160 kilometers to there. But I want to know, what's that little one in here? What's the little one on the inside? Well, we know from north all the way to south would be 180 degrees. If we've already got 160 degrees, that means that we'd have to have 20 degrees left over in there. So my theta, so this guy in here, is equal to 20 degrees. Now, because we're going to start doing some trigonometry, believe it or not, that's why it's in this topic. Well, that's why bearings is in this topic. We're going to be starting off by doing SOHCAHTOA. Now we're going to say to ourselves, well, if we're using SOHCAHTOA, which ratio are we going to use for this one? Okay. So we've got the opposite and we've got a hypotenuse. So hypotenuse and we've got the opposite. So which one uses those two? Of course, it's sine. So we're going to go sine of 20 degrees is equal to how far he's gone east over the hypotenuse, which is 75. So to get rid of 75, we're going to times both sides by 75. So times by 75. Let me write that properly. Okay. So that gives us 75 times sine 20 degrees is equal to E. So E must be equal to, putting it into our calculator, if it was turned on, 75 times sine of 20 degrees, and that is equal to 25.65 kilometers. So, therefore, boat has gone 25.65 kilometers east. Okay, that's it. So that's part A. Now part B is, what is the bearing of O from B? From B. Okay, so just going to redraw a little picture nice and small over here because I don't think I have enough space over there. Okay, so this is what it looks like. We know that this angle in here is 160 degrees, okay? What we're trying to do now is we're trying to find, well, what's this angle over here, okay? What's that angle over there? So if this is 160 degrees, that 160 degrees is made up of 90 degrees and 70 degrees because that 70 degrees has to be there. Now, using that alternative angles rule that we've been doing, so that one and that one, that means that this one in here is also equal to 70 degrees, okay? Because it makes that Z shape like that. So that one in there is the same as that one in there. So if this one is equal to 70, then this one here is equal to 70, okay? So using that alternative angles rule, okay, we can work out that that's 70. So the bearing becomes 90 plus 90 plus 90 plus 70. So 90 plus 90 plus 90 plus 70, okay? That's our... And then, oh, sorry, that's not anything. Then we're going to add it up, and then that's going to be what our bearing is. So 90 plus 90 plus 90 plus 70 is 340. So 340 degrees. So to finish it off, therefore, the bearing of O from B is 340 degrees T for true. Okay? And that's one done. Okay, question 7, which is the last question that we're going to go through. The boat travels 32 kilometers on a bearing of 160 degrees. How far east to the nearest kilometers is its starting point? I believe that's almost exactly the same question as what we had before. The only difference is that the amount of kilometers that has traveled has changed. And this time we're actually asked just to find how far east to the nearest kilometers is it. Okay, so let's draw a picture. Compass rose, north, south, east and west. Okay, a boat travels 32 kilometers on a bearing of 160 degrees. Well, whereabouts is 160 degrees? It's like probably somewhere over here because, well, we know that because we just did a question with it. Okay, 160 degrees. How far east to the nearest kilometers of its starting point is it? Okay, well, it's traveled 32 kilometers. Okay. And what we want to know is, well, how far east away from its eastern starting point is it? So basically, how far in the east direction has it traveled? So we'll put an X there, this time for east, or the east direction, or our unknown direction. Okay, so drawn a picture, step 1 done. Step 2, draw just the triangle and put our information on. 32, X, and 20 degrees. So just like in the previous one before, to work that one out, we know all the way south, so including that part here, it must be 180 degrees. So 20 plus 160 makes the 180. Okay, and because we're doing trig questions and because we always remember to do it, we're going to write SOHCAHTOA on the top, and we're going to use that to help us find, well, which one is this? We have an opposite, a hypotenuse, we have an opposite, it must be sine. Again, funnily enough. So sine theta is equal to opposite over hypotenuse. Okay, so sine theta is equal to that. So what we're going to do next is we are going to substitute some values in. So sine 20 degrees is equal to, opposite is x, hypotenuse is 32. Okay, multiply both sides by 32 to make the x by itself. And we get 32 times sine of 20 degrees is equal to x. So x is equal to 32 times sine 20 degrees. Okay, so it's traveled 10.94 kilometers in that direction. Okay. So, with that being said, that finishes off our trig topic. Bearings is hard. If you feel like you're struggling, don't stress too much about it. Bearings is hard. It's really, really hard. We did a lot of, like, the examples we've done, they're very hard to begin with, okay? They're not easy in any way, shape, or form. So please make sure, if you are struggling with this, don't feel like you have to get this done, okay? We understand that if you can't quite get it yet, it should be okay. But with that being said, I'm expecting that by the time this video comes out, we'll be back at school 1 day a week, and we'll be here to answer any questions about this stuff that you need, okay? So please make sure you do ask about this stuff, okay? And any other the trig stuff that we have done this term. So that being said, that's the end of this topic, and we will jump into our next topic for our next lesson. So I will see you guys then.